We're here with Eriksun Energy. We got Steven back for, I think, been here a 3 times. And Mark, first time on here. Thanks for joining us.
Thank you.
And we got our medium voltage, high voltage team here, our specialists. You guys are still crushing it. I know I keep hearing the story, but now we get to call you too when we get customers that need some help, and we just did one of those. But I was kind of hoping we'd talk shop. Teach us a little more about what you do.
Well, a lot of what we do is specialty work. I like to tell my guys sometimes the guys are like, Steve, we want preparation, right? We want to know what's going on. We can't always have all the information. Most of the time when we get called in, we have minimal information. It's an emergency. We're the last resort, right? Like you got to put on the cape. So there's a lot of times where you don't find out what the full intent is until you show up. That job we just did for you guys yesterday.
Thank you.
To be exact, and finished it today. Plan sets were wrong, common stuff. Maybe 60% versions, maybe an earlier version. Had some switches that were identified, found out that there was only one switch instead of 2 or 4 switches. Digging into transformers that have been offline for over a year, well over a year, stemming from different issues. Go out to understand physical, visual inspections, check on the mechanics, transformer testing, just to get an understanding of where the assets are, right? So we get a lot of stuff like that outside of things where, obviously when we have a thermal event or something fails and it turns into an emergent matter. But sometimes we're going out there to do a basic health check to verify, okay, is it safe to energize this transformer? Do we need to make a recommendation to the client to change the transformer, maybe repair the transformer? Sometimes the goal isn't always to put brand new assets in or necessarily replace existing access, but like what can we do to get these assets where they need to be and monitor them for a short term or a lifespan and try to make it so that the customer gets as much ROI as possible.
Okay. Yeah. And the one that you're just doing for us, I think it was like a change of hands and ownership a couple of times.
Yeah.
So then the person that's owning and operating it today maybe didn't have all the information. Some historical things were missing. Tell me more about. It was a transformer.
So there was it was a PV site. It was one of the commercial rooftop style sites, not a huge site. They had like 12 to 14 260K inverters that were, site was built in like 2012ish probably.
Okay.
So
been around
a little over a decade old. They had 4 26 kV to 480 MVT transformers out there to intercept the current building's medium voltage tie-in, which I forget the voltage there, but it was just over 26 kV.
All right, I'm gonna ask you to hit me up with those acronyms. kV.
Kilovolts. So that basically means 26,000 volts. That was a 26.4, so that was 26,400 volts was what that system was.
And MV.
MV.
Medium voltage.
Medium voltage.
All right. I'm just trying to help. We got a lot of listeners, and I hear more about we got more and more younger techs that do listen and look for the information and knowledge. So I'm just going to.
You know what, too? It's confusing because a lot of people hear MV and it confuses them because they're used to low voltage, medium voltage, and high voltage. And a lot of people think that once you cross into those areas where you're above like 1,500 volts that you're actually in high voltage, but it's not true. You're actually in medium voltage.
What are the thresholds?
I think it tops off at 69 kV is where it switches to high voltage.
Yeah, and the funny thing, and here's where the part of that is. The electrical industry has one standard. OSHA has a completely different standard.
Ah.
So OSHA has low, medium, and high.
Mm-hmm.
Low voltage is 24 volts or less. Medium voltage is 24.1 volts up to 599.9 volts.
Okay.
And then high voltage for OSHA is 600 volts or more.
Mm-hmm.
And what is our national electric code? Is that the other governing body? Or?
The NEC is like Steve said, it's basically low voltage is 480 or less.
Mm-hmm.
Medium voltage is 480 to, it'll float, but 34.5.
Okay.
High voltage is 34.5 and up.
Okay.
So again, that's kind of, in on the transmission distribution side of in the utility scale, they're looking at it from where does it lie on the pole.
Mm-hmm.
So if you look at a typical pole, you'll have 2 layers. So your commercial residential is the lower layer, your transmission distribution is the higher level, and then anything that's coming off of the pole, low voltage.
Interesting. That makes total sense. And that's easier to remember.
It is.
Much easier to remember.
But that's where, the medium and high voltage piece, people are like,
I know. I appreciate it. And forgive me if I ask a lot of these kind of, maybe to you, sillier questions, but,
Some people don't know.
Right.
Yeah. I get this question. I get this question from a lot of our technicians in the beginning. It was like, so what's the medium versus the high? Because they look at a 34.5 circuit and they're like, this is high voltage to me, but it's really not. It's actually medium voltage. So, and then Mark's right, like OSHA classifies it completely different, right? So OSHA has their own set of rules and they use these terms in there. And the terms that they use are because they want to put a safety second on site and things like that. I mean, we dispatch a second technician no matter, none of our guys work alone. They can't because of the exposure. So,
gotcha.
But yeah, it's kind of like, I think a lot of people wonder it. They see it, like they see, okay, MVHV, they hear medium voltage, high voltage. I think a lot of people associate medium voltage and high voltage in the same category, but there are thresholds where they change. I'd have to check what they say, but I'm pretty sure it's 69 kV is where it cuts off and it transfers into the high voltage side of things. So we're getting ready to support a 230 kV outage here in a few weeks, and
wow,
that's on the high voltage side of things. So
okay, all right. So tell me what it looks like then. If you get a lot of these emergency, you call them calls because something went down, something's wrong, and maybe you don't have all the information. That seems common, I guess.
Yeah.
That's unfortunate, but all right. What do you do first? How do you approach that?
Generally, what we like to do. Sometimes the requests aren't always coming in from site personnel who are on the project. I like to try to touch base with that personnel prior to the dispatch, try to find out as much information as possible because we're trying to be as prepared as possible. In your case, for the job that we just did for you guys, we were able to service 4 other sites. We're going to this week on our way back from the East Coast. So that put us in a position where we were able to go out with a full outfitted truck, be prepared for a lot of these cases where sometimes you're already on the road or it's a piggyback off of a different job. What we generally like to do is touch base, try to figure out as much information as possible. There's the intel or the recon doesn't stop until you get there, right? Sometimes you get there, like a lot of the first things that I like to ask when we walk on site is, what are your symptoms, right? What are you experiencing? Take me to the places where you have smells or places where you heard noises or maybe you saw an event, right? Kind of gather your own intel, do your own recon to kind of understand the circumstance that you're standing in front of and then act from there, right? So you definitely don't want to come in and say, okay, we're just going to go full bore and just go for it, right? You also want to try to get as much information on documents as possible, understand, each substation is different, each sub-circuit's different, it's different equipment, different layout. Part of our first job is wrapping our head around the site design and understanding not only implementing our safety procedures and the stuff that we consider standards, but touching base with the site to make sure, as Mark has said with me over the years forever, we always go for whoever has the most strict policy, right? So if we show up and the site's policy is more strict than our policy, then we're going to adhere to the site policy and vice versa, which happens often. We often show up to sites that are a little bit more lax than us, and sometimes we have to do a little bit of re-education and say, listen.
Are you talking about safety policies?
Yes.
Sounds like safety.
Yeah.
All right. Nothing proprietary, so always go with the safest policy.
Yeah, I mean, it's you look at it, and like Steve said, sometimes sites have been there or companies have been there and they haven't necessarily updated their policy. So,
Sure.
NFPA 70E, perfect example. it updates every 3 years. We're due for an update coming any day now, right? So, but when was the last time your electrical safety policy was looked at to make sure that are you in compliance
Right.
with the new one? And so, I look at those all the time and making sure that our policies are updated all the time.
Okay.
So that way, when we get out there, hey, there's a change. The big piece now for the coming up is NFPA 70B,
Okay.
which is now tied to NFPA 70E.
B as in boy, Bravo
B as in boy,
comes
which,
after Echo. Okay.
well, it's
I'll
because
follow along.
Echo came first because the E was electrical.
Oh, okay.
Okay, because it's the arc flash.
Thank you for telling me. Yep.
Where B is really designed for maintenance. And it's like, hey, if a company doesn't have a maintenance policy around electrical equipment, here's the new guidance document.
E stands for electrical and B stands for maintenance.
Well, that's
I don't know what. Like,
hey, I'm just
I'm gonna write it down.
but 70B basically says if a manufacturer doesn't have a maintenance plan or policy, then 70B is to be used as a guideline to establish that.
Yeah. Okay.
And so like what Steve was saying is when we show up at the site, do they have those pieces as part of their electrical safety program?
So if I'm responsible for a site and I have a medium voltage or high voltage outage, when I call for help, I should know to have my safety policy ready. I should have my as-built drawings. I should probably have gathered some equipment labels. Hopefully they're on file. If not, you can snap a picture, right? So we know what the equipment is to talk to you about. And then all of my observations. What occurred, how, when.
So generally what we walk into, Adam, is a switching procedure that's been prepared for the work that night, right? No matter if we're dealing with pulling an additional outage to like a forced outage that's actually in place, say, utility had an under voltage or over voltage or, a phase to ground event or something like that caused a trip that wasn't expected. We're generally looking for a switching order. We're generally looking for drawings so that we can verify the circuits. I would love to say that I would look for unique identifiers on equipment every time, but the one we just did for you guys didn't have any of that.
What's a unique identifier?
When you have a plan set, generally what happens is you have an equipment ID, or what I refer to as a unique identifier.
Okay.
This is basically a label, like the nomenclature.
Make,
of that
model.
set. Well, no, this is like, let's say, Transformer 1, to make it easy, or PCS 1,
Okay.
or Switchboard 1, right? Or it could be 2 or 3 or so forth and so on. That unique identifier is so that you can match the drawings to what's physically on site.
Gotcha.
And write the switching order so that it's proper. And not having these things in place can cause a little bit of confusion, and it could cause a safety circumstance if someone doesn't understand the actual design or if the proper steps aren't performed to understand that design. Like when we got out there, one of the things that we did, since we were already in an outage for your situation, was try to identify what they did here, because clearly after looking at the drawings, what I had was not 100% accurate, right? So now we have to kind of make sure the site's in a safe state where we can actually do some investigative troubleshooting to understand the circuit design and understand what whoever built this site did, and then kind of take that from there, right? And that also sometimes helps you in this case where we're going out, where we have a transfer ownership, it kind of helps you understand the circumstance and provide guidance to the client at that point, so that you can kind of touch on the things that are maybe shortcomings. Like one of the things that they asked us to do is, hey, the next time we pull you guys out for service, can we get unique identifiers on the equipment with a red line on the drawing so that we can correct the issues that we found?
I bet that the folks on site, the leaders or key people that you're working with, learn a ton that they didn't know before after you guys leave.
Oh yeah, yeah.
Right? I mean, their documentation is improved. It's now they have files. Now they have more knowledge and information about their own site when you guys leave.
Well, and this customer had an electrical contractor, master electrician, not only on staff, but another contractor like on site.
Oh.
And they were kind of like, hey, we do this. We don't even dabble in that. So there's learning experiences where people learn stuff, right? So like this particular case, we were testing transformers that were a Y configuration to a Y with an internally bonded neutral, which is impossible to get an insulation resistance pass on that circumstance because the two windings of the transformer are technically bonded together internally. So the only way to get an insulation pass on a transformer that's a Y to Y where you have an internal ground bond is to actually drain the tank and disconnect it. So you kind of get into a circumstance where someone normal would walk into that case, right? And they would say, hey, it looks like this is a fail, right? Because it's giving you an immediate short circuit. That's not the case. It's just a transformer design circumstance that you have to be prepared for. And you have to understand. Now, it does limit what we're able to do from just walking up to the unit, pulling an outage, hooking up the proper test equipment once the transformer's been isolated. So at that point, we have to do an insulation resistance test from HV to ground, LV to ground, gather those readings, and then perform the other acceptance test, TTR, WR, and kind of have an understanding. And it's unfortunate, but that's an actual transformer design that you're not able to actually achieve a successful IR result from the Y to Y when it's internally bonded.
We'd like to thank our sponsor, Altair Energy Services, and their highly trained, expert technical staff, leveraging decades of renewable power management experience into customized solutions for everyone to meet their energy goals and contribute to a better future for all. Altair's team of hardworking, respected experts are providing full-scope, turnkey repairs, planned and unplanned maintenance, system upgrades, fully autonomous technical crews, supplemental staffing, and customized dynamic scheduling to fit your power production needs. Contact Altair at info@altairenergyservices.com and learn more about their wide range of capabilities across multiple power technologies and platforms.
Gotcha. Transformer.
All right, we're gonna do acronym recap here. You just listed off like 9. And I appreciate you calling it an insulation resistance test and not a Megger test.
Yeah.
We had that on here. Too many people call it a Megger test, but it's not, right? What do you use to do your insulation?
So we use a Megger MIT 1525. That's a standard issue for us because we operate in the medium voltage and the high voltage sector. A lot of stuff that we come across, like surge arresters, CTs and PTs, especially in the PV world.
Current transducer and PT?
Current transformer.
Transformer.
And potential transformer.
Potential transformer. What was TTR?
That's transformer turns ratio.
Transformer turns ratio.
WR is winding resistance.
Winding resistance. See, you're educating me. I think I knew this at one point in my life when I was studying these things, but I have way forgotten. And there's not enough folks that I think know the different components and parts and different tests for transformers. So.
And when you say current transformer and potential transformer, they're a transformer in the sense of design as far as they're doing the same thing a power transformer does, right? They're stepping a voltage down. The purpose for the step down is a little bit different. Current transformer and a potential transformer. Potential transformer is what's utilized to measure voltage from a metering perspective. Current transformer is used to measure amperage from a metering perspective. So basically what these devices are they're basically step down transformers that accept the primary voltage, and they step it down all the way to an acceptable secondary, which it's kind of like...
And that's just for testing purposes.
It's for metering purposes.
Yeah.
So what generally happens is it steps it down to an acceptable secondary voltage that a piece of equipment can accept.
Yeah.
And the same way that you have like a ratio on that, once it hits the metering equipment, there's an automatic algorithm that reapplies that ratio backwards to get you to that point. So you're basically taking your medium or high voltage, stepping it down to an acceptable secondary voltage that a device like an SEL relay or a meter or something of that nature can accept. And then the meter is performing an algorithm based off of the specifications of the PTs and CTs involved to get those voltage and amperage readings back to where they can spit them out as medium voltage and high voltage.
Right, because your meter can accept what ranges, voltage and current.
Usually they're in the hundreds, so you see a lot of stuff where you have PTs that are like 100 to 1 or something like that, you know what I mean? So it really depends on the system and what you're standing in front of and what your primary voltage is, because that obviously affects how much you actually have to step it, right? So there's a lot of different configurations, but generally that voltage is generally in the hundreds.
Okay. All right, thank you. Man, I'm learning stuff. I never worked in the medium or high voltage space. Never.
And just to kind of tie with it, there's not a lot that do it because you have to do it all the time. Otherwise, you forget.
Oh, yeah. Right.
It's one of those skill sets when you look at, when's the last time you did something? From a safety standpoint, it's like, is this something you do once a year? Or is this something you do every day? Where am I, from a safety guy, which one am I more concerned with?
Right. The ones you're not doing.
The ones you're not doing.
Yeah.
But at the same time, the complacency on the second one, because they're doing it every day, they become more complacent at it. This one, their heads up will be, they may ask a few more questions, but the skill set is such at a higher level that you may have to go back and get retrained to do that skill.
Right.
Yeah.
Yeah, makes sense.
Well, it's interesting too, because understanding the testing piece, right? The testing is the most critical piece of what we do, because testing can tell you everything, right?
Okay.
Well, I shouldn't say it can tell you everything, but it can tell you a good majority. If you're having a problem, what kind of problem you're having, it helps with a lot of the assessment, right? Like for that case for you, we were requested to go out and energize some transformers that had been turned off for 2 years almost.
2 years.
So it's like, first thing I said to Ross when he called me was like, hey, look, we can't just go turn this transformer on. I need to do a visual mechanical inspection. We need to do electrical tests, acceptance tests on these transformers, understand where the transformer is from an electrical perspective. We'll pull a DGA so that we can get an analysis on the
DGA?
on the oil. Yeah. So dissolved gas analysis.
Yeah.
And then that'll kind of give us the whole picture, right?
Okay.
So it's important to know that because, like, for example, we had a client, we went and repaired a transformer because we do a lot of transformer repair where we're actually swapping bushings, where we're draining the transformer tank down, swapping high voltage bushings, low voltage bushings, sensors, gauges, right? All the things that help make sure the transformer is running properly. And when I went out there, we had a situation where we had to remove the T-bodies from the high side to do the test, because you have to. We had a little bit of client pushback. What we ended up learning was that the last vendor that was out there that tried to perform this work never requested for the T-bodies to be removed.
Oh. And
then I got to break the bad news. Nobody tested your transformer the last time that they did this work.
Oh, but they paid for it and thought it was done.
They thought it was done, right? And this is where...
Shame on them.
Oh, 100%. I mean, part of our job is educating, right? Not educating because we're like, we don't hold education back because we're afraid that the customer is going to self-perform or try to self-perform.
Right.
Generally, they still come to us for the service. But the education piece is so that they know that when they don't have us standing in front of their site and they're not in good care or could potentially not be in good care, they know the things to look for to draw red flags, right?
Right.
Because, energizing a transformer that you don't verify the electrical parameters on and have an understanding on that could lead you into a thermal event or a really bad circumstance, right? So the whole time we're out there, we encourage questions. We try to give the answers. We try to teach the people who are on site as much as we can, not just so that they understand what we're doing, but so that they also understand, okay, if I have a forced outage and something trips and we have a problem, it also helps us on the return when they bring us back out for the dispatch to say, well, we've already looked at this. This is the symptoms we're seeing. And a lot of times you can kind of get some better information, and you can teach the people who are on site to give you the information that makes that dispatch that much easier the next time you have to be there.
Mm-hmm. I love this. Too many people are scared to share that knowledge. You guys are leaning right into it.
No, you have to.
Yes.
You have to, man. And it's not just that, but it's about keeping the site personnel safe too, right? You know, we recently had a transformer here on the West Coast. We got hired to go out, replace the low voltage bushings, which requires us to drain the transformer all the way to the ground. When I did an inspection on the gauges, because one of the things that we always do, and a lot of things that O&M companies overlook, or what I like to call check the contractual boxes on. All right, cool. We need to do a visual inspection on the gauges, right? So what you generally have is a guy who has no idea what these gauges mean. He's snapping a photo of the gauges, putting them in a folder. Yeah. Somebody's never reviewing them, right? So they don't know if, okay, hey, my oil level is low based on the ambient temperature of the oil from when this picture was taken, right?
Yeah.
Or if you're not seeing a positive nitrogen blanket at the appropriate level of nitrogen. These are all things that can lead to underlying issues that could lead to corrective maintenance down the line or a catastrophic failure. That transformer was actually swelling.
Oh.
So when I opened up the instrument gauge, you could actually see it kind of forming a bubble on the back wall. It was no longer
flat. It was
right?
Convex.
And we ended up taking a torpedo level and sticking it, because it was hard to capture in a photo. Sometimes these things are hard to see in a picture.
Sure.
So we ended up taking a torpedo level and putting it against there so that the client could see the rise on the actual gap from where it was. Now that's a problem, because when your transformer swells, there's a good chance that you have an electrical issue that is causing your oil to overheat and is causing that transformer to deform. Right, this is a big problem. So we ended up pulling that transformer out of service for this one.
Is it pressurized?
It is, yeah. I mean, so that was the other issue with that transformer. When I walked up to that transformer, it was like positive 4 psi with the nitrogen blanket, which should have been like more like 0.25 to half a psi.
Oh, very low.
And and then when we drained it, because we always relieve the pressure off the transformer before we drain it down. When we went to fill it back up,
it'd be squirting out of there.
Oh yeah.
Yeah, gotcha.
It wouldn't even hold a nitrogen blanket after that.
What's a nitrogen blanket?
So it's N2. So in a hermetically sealed transformer, you apply a nitrogen blanket to basically put positive pressure into the transformer so the transformer doesn't go into vacuum, because you don't want the transformer to go into vacuum. That's bad news bears. So basically what you do is
you're adding
you just add nitrogen.
It becomes a hydraulic. It's oil and air. Now we've had to
they call it a blanket, because what it does
is it a bladder of some sort, or
so it sits on top of the space between the oil and the top of the tank.
Okay.
So that nitrogen kind of fills that area of where you have that air gap between basically where the oil level is and the top of that tank is.
And it's to add a small amount of positive pressure.
Small amount of positive pressure.
Okay. Why nitrogen?
Could
you use air?
Number one, nitrogen, the characteristics of it, it's not going to corrode the inside of the tank.
Yeah.
Okay.
So when in mixing, it won't mix with the oil.
It's just free floating? It's not like in a bladder?
No,
it's free floating.
Okay.
So take
now I get it.
Take,
I was imagining a bladder in there. Like a air compressor.
No.
Yeah.
No.
So if you took this here, the oil's to here, the red is nitrogen. So it fills the gap.
But you say blanket. I think that's where
well, because it because it just blankets
the top. Blankets the top.
Yeah.
Right. But so the idea is it's an inert gas. So, the same thing, why do people put nitrogen in their car tire instead of air?
I don't do with that, so I don't know.
So the nitrogen
should I be?
The nitrogen molecule is bigger than an air molecule.
Okay.
So your air, you will let your tires full of nitrogen will less likely leak than if it was full of air.
Do you put nitrogen in your tires?
Costco has been doing it for years. They
What?
started, yeah. Because what they were doing is people were coming in saying, "Hey, my tire's low."
Sure.
Well,
yeah, every winter.
Because of the temperature.
Every winter.
because
Yeah, guaranteed.
Yeah.
Span of contract. Well, the nitrogen will take that expansion and contraction at a better rate than normal air. Air.
So the next time I come to town, I'll bring the nitrogen bottle with me, and we'll get a blanket in your tires for you there.
All right, perfect.
We're getting close to cold out here, you know.
That sounds good.
But that's it, the idea is to increase fuel performance and all that kind of stuff. You're less likely to do it. So it's the same thing on these transformers. Is having that nitrogen blanket in there. It's an inert piece. So now it's to help prevent, like, doing in the DGA, the dissolved gases. If there's something in that oil, it means that nitrogen is not doing its job.
Gotcha. All right. Thank you, man.
It helps pull the oil sample too when you have the positive pressure, because it allows the oil sample to free flow, and then one of the big things you don't want
negative. You crack the valve, you get
not just that, but you don't want air inside your oil sample, and you want to try to reduce the amount of air in the sample. That's where the N2 really comes into play.
Okay,
is making sure that there's not empty space above there, and you have to be careful because you can put too much nitrogen inside of a transformer. So you have to judge the N2 blanket based off of the temperature of the oil and things of that nature. There's an actual chart and stuff, so I can share that with you if you're curious on learning.
But all right, yeah, thank you. But now, what caused that swelling? What happened in there to that increase of pressure? You said it should be like a quarter pound, and it was like
it wasn't enough positive. The pressure didn't cause the swelling, in my opinion. There's probably an electrical breakdown. That transformer also failed an insulation resistance test pretty miserably. Generally, when that happens, when you have an electrical issue inside your transformer, it can actually cause, just like if you have a PV module connector that has an air gap, it can actually cause a heating sensation where it can actually cause the temperature of the oil to rise higher than it should be. And depending on what that temperature is, it can actually cause deformities to the tank itself.
Okay. So temperature increased.
Yep.
Which is going to raise pressure.
That's what I think happened, yes.
Okay.
So think of it as you're doing French fries.
French fries?
Yeah,
all right.
Put the frozen fries in the oil.
Yes.
What's the oil do?
It's going to bubble.
If you put a cap on that, you're building the pressure.
Yes.
Same idea.
Yeah. So it failed insulation resistance. That's going to increase heat or create heat, I guess, isn't it? Right.
Oh, yeah. Well, especially if you have an insulation breakdown.
Yeah. What causes that to break down? So this is in the oil.
So the insulation failure is actually in relation to the windings of the transformer.
Okay.
And everything basically from the high side connections to the low side connections.
Yeah.
It's hard to say what causes it to break down. It could be
like they just get old,
defective, could be old, could have faced an electrical circumstance where it was overrated and it broke down that insulation. There's a lot of different things that cause it. It's hard to say exactly what causes it.
Power quality comes into play here.
Oh, yeah.
Joe Chacon, Podge, talks to me about this all the time. Power quality. And he's very supportive of power quality tests on transformers. He goes, I don't care what the nameplate says. Let's go find out what it's really doing.
So, and that was another point that I made for the job that we dispatched for you guys, right? Because we identified one, we identified one transformer that had a tap changer that wasn't functioning. And the tap changer basically changes your incoming voltage, and it can affect your secondary voltage, right? One of the things that I was trying to explain to them, because we had some TTR tests that were quite a bit outside of what they should have been, right? So when they deviate too far, that affects what your output voltage is on the secondary side, depending on what your input voltage is on the primary side. And that was one of the things I was saying.
The insulation breakdown caused the transformer turns ratio test to fail?
It can. I mean, it depends how bad the failure is. In these cases, these were pretty minimal failures they were based on the standard, they were considered a failure. It wasn't a catastrophic failure to the point where it's alarming to energize the transformer. What's alarming about it is it's going to affect the output. So like say if your tap is rated for 26,400 volts, right? And you deviate and the output of that is supposed to be 480 and you're deviating 6 or 7%. That's going to put your output voltage from a theoretical sense at like 508 to 510 volts instead of 480.
Gotcha.
Where this gets to be troublesome is most of your PV inverters can only handle a certain range of voltage on the low side and the high side. So generally we see ranges from like 420 to like 520 or somewhere in that essence. So if you fall above or below that threshold, it a lot of times will fault the inverter and cause the inverter not to run. Now, where it gets even deeper is you're doing a theoretical equation thinking, okay, this tap is 26,400 volts, right? However, from experience, we know that the power company does not always provide you with the voltage that they contract you.
Right.
So we see a lot of things, and that's where
I've never seen them provide me with the voltage.
No, 100%. And a lot of times before PV, I talk about it all the time. Before PV converters, they got away with it because most people who are running commercial businesses, running their home, they don't have the tools in place to understand the quality of power that they're receiving from the power company. So this comes into a question too, because if your deviation is far enough off and then your voltage is out of range on top of it, it could actually spin your secondary voltage to a point where it will not allow the inverters to run.
Right.
So understanding power quality is probably one of the most overlooked circumstances in our industry, because people just assume that the power that they're receiving is the proper power.
No.
But there are often times where advanced cases, we actually look into them. Even when I was on the PV side very heavy, there were a lot of cases where we found out that the power that we were receiving from the power that the customer was receiving was definitely over under. I had a situation at my last company when I was in Pennsylvania, and we had a circumstance where all the inverters tripped offline. We had a bunch of SunGrow inverters, right? They were 3150s. They were all tapped at the 34.5 tap. The inverters fell offline every morning, constantly, for like a week. We couldn't figure it out, right? So finally, I went out there. I looked at all of the relay data because we had real-time relays in place to measure that data. And we found out that they were actually delivering a voltage that was less than the relay could accept. And in turn, it was feeding less voltage to the tap than the tap was set up for, right? So the tap is looking for 34.5. I think they were feeding it somewhere like 31 or 32, was something around that range. Well, when we called the power company, they told me that they weren't doing any work. They don't know what's going on. This is strange, blah, blah, blah. Well, when I went to site, the air switch that we generally utilize to isolate the site had utility companies lockout on the air switch.
Oh, yeah.
I finally got a hold of somebody, and they finally admitted that they were performing work upstream. They had moved the POI at the substation to a different substation to provide power to the site. Exactly. So they moved that, and because they moved it, it was actually the new substation that was feeding that site was further away, and it caused a voltage drop. And that's where the drop in voltage came from. So we actually had to go out and modify the relay settings to accept a lower voltage. And then we had to go out and modify the tap on every single inverter so that we can maintain the inverter's operation until they were, and finally at that point they were honest with me and they told me, and I said, well, listen, just tell me when you guys are done. I'll make the adjustments on the relay. We'll make the adjustments on the taps to get the inverters back producing so the client can still produce power. And when you guys are done, tell me, and we'll go back and revert it back to the old way the day that you guys are ready to bring the power back from the original point.
Makes sense. All right. Explain to us what a tap is. It's the point where it connects on a winding, right?
Yeah. So it's basically changing your transformer to accept a different input voltage. So generally on an MVT for PV inverters, right? Generally you have 5 taps on that unit that can modify that transformer to accept a different primary and still achieve the same secondary output voltage, because the secondary output voltage has to be the same no matter what. So obviously that turns ratio is a little bit different if your tap is set to accept, like, let's say 30 kV instead of 34, right?
Yep.
So if you have a different power source coming in from the power company, generally on sites it's 34.5. I mean, I can't say for a fact outside of like doing some modifications on the last one. Almost every site we walk up to is a 34.5 site. We're generally operating on tap 3, which is generally a 34.5 tap. But that's what the job of the tap does. It puts that extra turns ratio in place so that you have several different options of generation voltage that you can input into that transformer to still give you the same secondary result on the secondary side.
So helping us. So let's just say this is a transformer, right? And
Yep.
we see our wraps right here.
Yep.
Yeah. And if I connect here, I'm at one ratio. Here's another ratio. Here's another ratio.
Yep.
These are the taps, the point. And how is it a switch? Do you
a switch.
actually have to physically move something?
It's a switch, yeah.
It switches.
Yeah, so it's a rotary switch.
Okay.
I may have a photo I can show you.
Yeah. I don't know. I mean, I know the theory well. I don't actually know the heck
Maybe I'll send
components and how it works.
Maybe I'll
I shouldn't say I know the theory well. Somebody's gonna ask me a test question.
maybe I'll send Jacob a photo so he can flash it
Yeah,
on the episode. You know,
that'd be perfect.
so this is the tap changer.
Yeah. Okay.
So it's basically just a rotary switch. It's important to note.
Is a pin of some sort, or is it a bolt?
So it has a screw that locks it down.
So it doesn't move.
Yeah, so it doesn't move.
Mm-hmm.
It's important to note for the viewers who decide that they are now MV experts. Don't move this unless you when it's under load, unless you are absolutely positive that it is to be moved under load, because you can cause some serious problems.
Yeah, we don't want to be MB experts, right?
Yeah.
We want you to be an MB expert. We want to learn enough so that we can keep our sites operational, do proper maintenance, know what information to give the experts to get the help we need to get our site back online.
Exactly.
That's really what we're looking
Exactly.
for. What's Up Renewables is growing, and we're looking for new sponsors to join us. Our show connects leaders, innovators, and field professionals across the renewable industry, and our sponsors are part of that conversation. Some have seen their network expand instantly. Others have grown revenue and brand visibility through the connections they've made right here. If you want your company to reach the people driving the future of clean energy, now's the time to get involved. Contact us at media@whatsuprenewables.com to become a sponsor today.
The one where you guys had that girl on here, and she was talking about going to the spa as a technician. I think I saw having a spa day.
Oh, Wendy.
Yeah, Wendy having
Yeah.
a spa day.
Right? It's not a bad idea. You know, it's funny. My back hurts now. I was just telling my son last night, like from traveling, it doesn't take much anymore. Last week, I was Austin a few days or something. And just 2 to 4 day trip now, by the time I'm driving home, my back hurts. Like, man, I've done so much of this in my life. I don't even want to sit in a vehicle.
I get a
Funny.
massage.
So spa day sounds really good.
I get a massage once a month, every month.
Do you really?
2 hours.
No kidding. Yeah. All right. Little physical, tender loving care. So
I don't do shit.
yeah.
I
No.
just work.
Yeah.
To me, it's one of those things that I just relaxed completely. My mind I'm out. My massage therapist will tell you that she works on me, and 10 minutes in, I am out.
Yeah, I need to do that. I go to the gym, and I love that if I work out hard, I can't think about anything else. Like so hard that the vision starts to go, then my brain doesn't think about work, and so it's an
Maybe that's
escape.
what I need to do.
But then, and I do have a hot tub, which is good because then in the mornings I'm like rolling into that thing to start moving again.
Yeah.
Yeah, but it really takes the brain away. I do yogas Monday night, 6:00. That you can't think about anything else. It's one of those things.
You're active, man.
So you're getting, I don't get a lot, so I gotta, I don't get any breaks, right? So you gotta
Well, me neither.
squeeze an hour in.
He was telling me last
the
night.
gym
I
or
was
something.
like, this past week, Lauren went to Disney with the kids, and I had to skip. This was the first time ever that I was like, I just got too much to do,
Yeah,
and I stayed home for 3 days, and literally worked from like 5 a.m. until midnight
yeah.
on the computer every single day.
Go to the gym with me.
Oh, let's go. Tell me.
I use the gym right here in Old Town.
Easy.
Nice and close.
Yeah. No.
Right? It's not much money, and it's 24/7.
Oh yeah, 24/7. He told me last night. I was talking to him. He said, "Go and spend some time with the family, man. You need to take a break."
And it's kind of to tie into this is, mental health care, physical care, it goes a long way. And so that's one of the reasons I got into the routine of getting the massage every month.
I like it.
It's just because I found that I carry a lot of stress in my massage therapist will tell you exactly where it is.
Back, shoulders.
Mid back.
Yeah, guys.
And I get a 2-hour massage. People are like, you get 2 hours. And I get 2 hours. She literally spends just an hour on my back.
Dang. The one person for 2 hours? Be a tired person after 2 hours.
No, she's
You need a break or something.
she's like in there. She goes and she just keeps going. And like I had it yesterday, and she found a spot. She goes, and she knows my back very well, and she's like, you usually don't carry stress right here. And she worked that spot for like 20 minutes, and I came out of there 2 hours. When I was done, I was like, I feel good now.
I used to do them, deep tissue massages, and I kind of got out of it. But I mean, like the really bad ones. Like if I'm not bruised for 2 or 3 days, it wasn't good enough. Kind of massage.
And that's the thing is,
painful, but it gets it done.
Yeah, we've worked together to find kind of that medium point, and so she doesn't even ask. She just goes, "All right, room's ready. Get ready. I'll be there in 5 minutes."
It's pretty good.
We'll buy a chair.
Yeah. So you can have your laptop on.
I have my laptop.
Keep working.
Yep.
Oh man.
It's got to happen.
Yeah. The price of the chair gets you a lot of massages, though.
Yeah, I mean, the price of the chair over the massage frequency could be quite cost effective.
It's funny. And you're younger than me. I remember when I was a bit younger, I would push myself like you are right now, and I could keep doing it. Now I can't. Like if I don't sleep well, if I'm not rested, if I'm not nourished, I'm not very effective anymore. Like when I was younger. And I know what you're doing to sacrifice. You're drinking this stuff and you're staying up at all hours and all that shit.
I don't need that to stay up is the crazy part.
I used to be able to, but like anymore, if I don't sleep well, honestly, I'll push my schedule and get my rest. And if my body hurts, I'll go to the gym, and then I'm so much more effective.
I asked the guys a couple weeks ago, we were out on a long stint in Utah, and I drove there that day, went straight to work from there, worked from 7 p.m. to noon the next day. And I asked the guys, I said, you guys think I'm crazy? They said, no, we know you're crazy.
Yeah.
You know what I mean? And he'll tell you that back in the MaxGen days, I was the same way. Like I just went, there was no stop. And I haven't lost it any. Caleb told me the other day, he was like, dude, I never in a million years thought that you 10, 12 years older than me, I'd be struggling to keep up with you. But part of it too is just I love it. I think I was talking to somebody about that just the other day, and they were like, who was I talking to?
You're talking to me.
No, it wasn't you. No, it wasn't you. It was a contractor. It was another contractor. I was talking to them, and they were telling me the same exact thing. Oh, your buddy that you hooked me up with, Tim. Okay. I was talking to Tim, and he was saying the same thing. He was like, I just don't enjoy being at the computer. Like it's part of the job.
Yeah.
But I just love being out there.
Yeah.
I'm the same way. I enjoy. Lauren says I do it for the clout, but I just love fixing things. You know what I mean? Like getting that the satisfaction where it's like, okay, this is a problem that most people can't tackle, and we're out there quick. We're providing service to the customer, and
total guy thing, right? It's binary. It's broken, it's fixed.
Yeah.
It's off, it's on. I'm into it too. Like same. When I get way too into work for too long a period of time, I need to go do something with my hands. I need to build something. I need to fix something.
Yeah.
I need that dumb guy binary
accomplishment.
It's
accomplishment.
Yeah. What's it when you're fiending and you need that fix?
That fix. Yeah.
Yeah. You need that guy fix.
But it's a satisfaction too, because with me, I like to show up and I'm just like, okay. I stand back and look at it, especially if you build something right, stuff like that. That's how I felt at Solar Star after we did that. I felt like, yo, man, we did this with our hands.
Yeah.
You know what I mean? Like they're producing power every day right now, more than they were
Yes.
7 months ago. You know what I mean? So
Totally cool.
it's an accomplishment when you take something from nothing, or you can build something. When I was a kid, I used to take things apart and try to put them back together. My mom would say, if you ever talked to my mom, she'd be like, Steve used to always be tearing apart old computers, toys, like all the circuitry. Well, what are you taking apart for, Steve? So I can put it back together. It's like, it's a sense of that. Sorry.
Maybe it's not a guy thing. I don't want to be ruling out any females or other genders out there, but some humans need that little binary fix. Yeah. So, all right, man. Dude, hit the gym with me.
Let's do it.
I mean, you and I always have enough to talk about on business anyway. We can talk at the gym.
We could talk. There's
no one in there will know what the hell we're talking about.
We don't have enough
anyway.
time in the rest of our life to continue talking.
Yeah.
At the level we need.
So let's start meeting. That's just where we'll meet.
Let's do it. You already ran into my guy that one time there. So.
That's right. That was kind of funny. This young guy goes, "Excuse me, you got a podcast?" Yeah.
It was RJ.
It was RJ.
Yeah, it was RJ.
He goes, "I recognize the beard." Okay, good.
Yeah, he's a good
Now leave
kid.
me alone. I'm working out. He's a good kid.
But no, back to the technical stuff. I mean, switching orders, all that stuff. We try to be as prepared as we can, right? I think the prep for us is the training more than anything, right? The training, the guys understanding the tools they have, but we never know what we're going to walk into, and every situation is different. I mean, you see a lot of similar situations. You see a lot of transformer issues. You see a lot of cable blowouts or T-body blowouts or things like that, bushing failures. But every time you walk into a situation, you got a different level of management. You got different rules. You got different policies and procedures. You have different designs, different equipment. A lot of these equipments share the same functionality, but different manufacturers have their own nuances and stuff. We dealt with a case recently up in Northern California, up near Sacramento. Site's still under construction. They had a bunch of transformers failing, so transformer manufacturers sent us out there to investigate, try to determine stuff. They had a miserable fail on transformer testing. Way bad when I retested it. Likely not even, we're not talking about like outside of deviation. We're talking about like this is catastrophic. We met with them.
So a short, something
there was
physically
there was
broke.
an open circuit on phase C.
Okay, open.
And possibly some shorting going on the other phases.
Okay.
I met with the customer who is a contractor. They're actually building the site. And they had some concerns about one of the other contractors that were sent. And they were basically concerned about some working on heights on top of like an inverter skid. And I actually get into the transformer tank and stuff like that. So me and Mark met with their team, and Mark found this. That's a vertical lifeline, a horizontal lifeline.
It's a horizontal lifeline, but it's really designed to work on top of these skids.
Of a C train.
Oh,
yeah.
I gotcha.
So it plugs into the C train. So it's got two posts that attach to the C train itself, and then it runs a horizontal lifeline where you can actually hook off onto there, and they were all about that. So sometimes it's not just about whose policy is this. All right, we have this in place in our policy. You guys have this. Sometimes it's about bringing the teams together to work towards a policy or a change that everyone's comfortable with. You know what I mean? So it's hard to say what we're going to run into every day. It's hard to prepare for every circumstance that you're going to see. But I think it goes back to, like I said, training, being prepped, having the right tools, having the right PPE, and getting that theory training. Like a lot of what we do is theory based. I tell guys, like, listen, you're never going to walk in front of a transformer that is identical to the last transformer. They're all going to vary, no matter if it's a kVA rating, the type of windings they are. Like I said, most of the stuff we do in the PV world is a Y to a delta, right? Or technically a delta to a Y. But like yesterday on your site, we walked into a Y to Y, right? So, I mean, you can never say that everything's going to be the same as the last. So you don't train specific to a unit. You train specific to theory.
Oh,
That way you can adjust with theory, and then that can apply to all the equipment you stand in.
So what's a Y? What's a delta?
It's a transformer type. So the The big difference is the difference between a parallel and a series circuit. So a delta is a series circuit where all the legs are connected, and then a Y has a common point where they all connect. So that's the big difference is series and parallel.
And why, not WYE, why would you choose a Y or a delta transformer for your site?
Well, it's all about start and finish, right? That's the easiest way that I explain it to people, because somebody asked me that, because I said that I told Ross today, I said, hey, a Y to Y is generally like one of the cheapest transformer types that you can buy. But what you have to understand is, in order to pick your transformer design, you have to understand two things. What are we starting with? What are we finishing with? What is the power coming in going to be? What is the power going out going to be, right? So on most solar plants, they have a little bit of design capability when you're like talking about a raw land site or a site that has dedicated transmission. On some of the DG style projects or the smaller projects, the rooftop jobs that are on commercial buildings, a lot of times you're adapting to the power that's already present, right? So that's the case that we were dealing with at that job that we went to for you guys. Their system was a Y with a neutral from the start. So that's where we're at, right? So anytime you have that, the transformer's job is to take said voltage introduction and spit out the voltage that we need going to the transformer, and then subsequently going to the inverter. So whatever that POI, that point of interconnect grid type you're dealing with, you need to be able to accept that and then spit it out the way it needs, which generally on solar inverters, ideally you want to go 480. You know, some of the older models, they had some models that were 208 models and stuff like that, but they were rare. But most of the time, you're looking at, on that side, you're looking at a 480 inverter. Now, a lot of the central inverters are doing 480 on a delta, you know what I mean? Because they're not looking for that neutral, you know what I'm saying? So, because they don't need it, they just need the phases. So it all depends, but there's inverters that are taking Ys. I mean, it's all about the specifications of the equipment that you're trying to bring together, because essentially that's what the job of the transformer is. The job of the transformer is to basically make it so that whatever circumstance you have from utility coming in can basically change that power method to deliver the asset, what the asset needs to actually operate.
Gotcha. All right. Now we're getting to design of solar sites, PV, photovoltaic. Yeah, that's pretty good. All right, man. You know your stuff. You know your stuff. Kind of like you were telling us, you know, if I'm taking care of a site, what to look for. Any other tips and tricks you might give? If you know, for the people that are in charge of these solar sites to take care of their medium high voltage equipment.
So when I worked at the prior company as the senior manager over operations, I had a saying that I would say, and I would always start the conversation with due to unpopular opinion, because people always disliked what I had to say.
Okay. We'll ask why that is later.
So we have a circumstance in the industry, right? And it's a problem that I used to bring up to him all the time when he was our safety guy back at the old place. You get guys who read these contracts and they have these safety clauses in these contracts that state if there's not a level of PPE, we don't touch it, right? Like if there's not a level of PPE that we can keep the technician safe, then we don't do the thermal scans on the transformer, or we don't do the internal inspections on the transformer, because a lot of PV customers are trying to avoid an outage at all costs, because that's ROI, right? Like they're losing money. And a lot of times when you're doing a thermal scan, the best way to do it is while it's running, while it's built up, while you have that heat generation on the actual termination, so that you can determine if there's an issue. Don't skip those checks, right? There are ways around getting the information that you need. There's better equipment out there that can accept the thermal image from a further distance away to put a technician at a safe working distance. There's drones that you can fly, right? So it's possible to shut down a site. We do it all the time. We have a drone pilot that goes out and does aerial thermal scans on substations and things like that. But it's like, hey, maybe what you need to do is open the doors and get personnel off site and get the drone in there to go get that thermal imaging, because not performing a thermal scan on your medium voltage and high voltage connections that's one of the first places where you can detect the signs of a catastrophic failure before it actually occurs.
Interesting. And technology on tooling is catching up to making this safer.
Yeah.
I love that.
The ability, the use of drones. If you look where we were 6 years ago, right? It was the big airplane drone that was doing the flights over the the panels, doing that. Now we're looking at more compact drones that the imaging is so much improved, and longer flight times, all those things. So a lot of it, and like Steve said, is one of our abilities is we have that drone and use it, and we use it
with a thermal camera.
Oh, yeah.
And the ability to do, one of the things that we do is we do side by side. So as the camera goes through, it's taking a thermal image and a regular image.
Oh, it has 2 cameras.
Yeah. And it's putting that video side by side. So when we're doing the inspection, we're looking at the visual inspection and the thermal inspection at the exact same time.
Okay.
Which provides a level of clarity, not just for us, but for the clients who know their projects, right?
Yes.
Like they can walk through this and basically understand, okay, where that physical video is, the non-thermal video, and comparing it side by side with the thermal. It actually gives you a point of reference on the actual flyover to understand what you're actually looking at on that project.
And are you guys doing this on solar sites or just for the MVHV stuff?
I mean, right now we're specializing on the MVHV side of things. I mean, we could do it for solar. I bring this up because it seems like it's common practice in the renewables industry to walk away from thermal image scans on transformer cabinets for what we just talked about, right? Not having the proper level of PPE to have a guy stand in front of that 34.5 dead front with a thermal camera to gather those photos. And like, those are my big advice tips. My big advice tips are, don't skip your thermal imaging.
How often should we be doing them?
At least annually.
Really?
Minimum. Yeah, because I mean, look, ideally, I love if you'd be able to do it monthly, but it's just not feasible for most people. But at least annually, at least having an understanding of what the thermal, because a thermal scan can detect a lot of big time failures before they actually occur. Another thing is understanding the gauges and the sensors within the transformer itself, like being able to understand,
know how to read them,
know
what they should say, what they shouldn't,
know how to read them. We get calls sometimes from clients that are like, hey, can you come pull our DGAs, right? And happy to do that, no problem, right? But what I tell them is say, hey guys, look, it's not cost effective for you to hire me to pull DGAs. It's really a simple process. I'll come do it. Why don't you send one of your guys out or a couple members of your team, and we'll train them how to do it while we're there so that you guys can do the DGAs. Because trust me, I would rather my guys be fixing real problems than pulling oil samples when that's something that we could train down and get other people to do that. Because there's real catastrophic failures that need our attention, not just pulling oil samples. But definitely the gauges.
Do they take you up on that? Get some of their guys trained?
Oh, yeah.
Oh, it's great.
Yeah. No, I mean, it's all about give and take, right? It's like, our goal is not to be there every day. Our goal is to be there when you need us there.
Yeah.
Right. And by doing that, it allows us to be there for more people that need us there when they need us there.
Right.
Right. So if we're just there doing routine stuff, and we do routine stuff because some people prefer to have us do the routine stuff on substations and things like that. But, we don't want to be the guys that are out there doing very routine, basic tasks. We want to try to get that education point going, and we offer it all the time. We say, if you guys are hiring us to go out and do a DGA and you don't have staff that can do it, send 2 or 3 technicians out there so we could teach them how to do it while we do it,
right?
So you can start doing it yourself.
Love that.
And the second part of that too is the education piece, right? If we can educate and help you, get the job done, that's going to make you, from a business standpoint, hey, good customer relations
Yeah.
builds confidence. Hey, so when you do have that problem, you're going to call us.
Right. Love that. You guys are doing it right. I love the knowledge sharing piece, the educating part.
So that's
brilliant.
I think one of the other things too, Adam, that I noticed is like, we had this problem on a substation not too long ago where they had a catastrophic failure. They had a B-phase to ground failure. I had made recommendations to test some surge arresters back at the substation at the sub-circuit. Didn't take my advice. I watched it blow up in my truck.
Oh.
And then we ended up replacing them and then retesting them. So, another thing that I tell people is, hey, if you had a failure where you have a phase to ground failure, you a lot of time have applied stress to equipment that is put in place to protect circuits from that kind of stress. And you need to verify the integrity of those components, right? So like, if you do have a failure, don't just go out there and put a flashlight on the equipment and look up at it from the ground and say, oh, it looks good, right? There's a reason why we do electrical tests, and a lot of those electrical tests are to verify the electrical integrity of these components before we re-energize.
Right.
So, don't skip the checks and balances, because the checks and balances could save you a very expensive breaker, or, even surge arresters. Most surge arresters are averaging $1,000 a piece, right? You don't want to get to a point where you're spending unnecessary money just because you didn't want to spend a little bit of money to vet the equipment, right? So anytime that you have a phase to ground failure, you're going to have a voltage imbalance on the subsequent phase. What's important to know is stuff like surge arresters, they have ratings, right? So, and there's also, if you have a relay on site, which most sites today do, most sites that operate in the medium voltage space do have a relay.
Sure.
You can look at those files and you can understand the voltages and the amperages, and you can read the electrical parameters to understand, okay, what changed during this event, right? Like, one of the most recent ones we had was 26,000 amps to ground.
Oh.
On a B phase. And I'm just fascinated with it. So I like to convert voltage to wattage,
Okay.
amperage, all that stuff. Like use the actual mathematics to convert it to stuff that's a little bit layman's terms, kind of.
Okay.
So we a lot of times convert those amperage failures to wattage and figure out what the horsepower was that went off in that unit when it happens, right? It was a lot.
That's insane.
To put it for people, that's like 7 to 10 dragsters taking off at the same time. Like, that's the amount of force that is.
Yeah.
So we like to do stuff, but
what is a cruise scud missile? You should compare it to shit like that.
Oh,
That's what Joe does. He's like, well, does your arc flash suit do this? Because this is what you'd need,
oh my God. Yeah.
So he tries to compare it to like, bombs, missiles. Yeah.
It's not
It's a lot. It's
comparison.
a lot.
Because when you tell that to the human, you're like, oh no, my suit won't withhold.
Oh, it's crazy.
It's not Superman suit.
But that's part of it though, right? It's like, it's that stuff, there's a lot of O&M providers out there that go after contractual obligations, that go after preventative maintenance contracts.
Sure.
MV is always part of it.
Yep.
I hate to say this, but there's very few that have qualified personnel to perform the inspections at a level where the inspection is valuable, right? And that's where a lot of times you get situations where they're overlooked. And I think more times than not, we fix transformers that have been poorly maintained. Not necessarily just, failures from like a factory perspective or something that's a manufacturer warranty, but also transformers that have been severely neglected.
Yeah.
And not identified at the early signs of failure.
By a person that's qualified to do it.
Yeah.
Yeah, I like.
So we were talking about 70B in a PA 70B.
Oh yeah.
This is where this is all coming together. Is people are not maintaining their electrical equipment to the level it needs to be maintained at.
Okay.
And so this is where the industry, and it's just not the renewables industry, it's just industry in itself. It's a problem across, and I've been doing safety for many years in different industries, and I'd see the same issue. not maintaining their electrical equipment.
Now we're getting regulatory guidance.
Yeah, because
criteria to do.
it's one of those things that people have known, that, hey, if we don't do something about this, it's only going to get worse.
Yeah.
And it's not shade at my O&M providers that hire us.
Sure.
Okay. But there's another problem, and it's a problem me and him talked about for years too. Me and you've talked about it before. We don't have enough professionals to service the equipment that needs to be serviced. And it's an industry problem. It's not a company problem.
Right.
It's not my problem or your problem or any other O&M company's problem. This is an industry issue that we are going to struggle to fix. And that's why what we're trying to do is we can't fix everyone's stuff. We're selective with our clients. We try to build good relationships with the clients that we have, and we try to take care of the clients that we have. We oftentimes are making those people. Right. And trust me, I have a kid right now who's 26 years old who is running major repair on MVTs every day.
Wow.
So like, it's not a matter of it can't be done or we're struggling to do it. You just have to invest in your people. Right. And we unfortunately are not going to get ahead of the curve of the stuff because the sites are being built faster than we can produce the personnel to maintain them.
I love how you said industry problem. I don't disagree. And it's grown so fast. So we all struggle to train enough new humans to make it happen. But I start to think about it. It's a society problem. Our society is so power hungry. We all want more, right? We all buy more things that run on electricity. And the fastest power plants you can build, solar, wind, right? Put in battery maybe, takes much longer to build gas, oil, coal, nuclear, like, I don't know, quarter century or something.
It's not even just that.
So you need it so fast, but why do we need it fast, right? We're a power hungry society.
Because technology is growing and it's growing in the power field. They talk about this, the politicians talk about this with, not to get political here, but the politicians talk about this with EV cars.
Yeah.
And they talk about, they want to put the country to EV, and they talk about the amount of charging stations that would need to be put in and the amount of money that it would take and the tax that it would put on the infrastructure on the utility side for the United States is insane, right? It's massive. I mean, look at what's happening with data centers right now, right? You're going to see a huge shift. Sorry to our people in renewables, I apologize, but you're about to see a huge shift and a focused move from renewables to data centers, because the AI technology that people are relying on, depending on, and utilizing day to day is creating a huge need for data centers that they are going to move. I have an opinion that they're going to move government subsidized money into data centers so that they can help get these data centers built.
We talk about it. It's time. We have to now feed the robots we just created.
Yep.
Feeding the AI. This is every bad movie right now.
Yeah, and to go in,
Right? This is our, yeah.
to go into that too is when you're talking about the data centers, and we were talking earlier about power purchase agreements. They're not going to the utilities anymore. They're going to Amazon. They're going to Microsoft. They're going to Apple. They're going to support. So those data centers are getting guaranteed power.
Yep.
It sounds like battery storage, from what I'm gathering, is their quick fix.
It is a
So
quick fix.
they just put in their supply and then make sure that they can suck enough off the grid when needed, and then push it back when it's low.
Well, and back to your comment about society, right? So there's another side of that society predicament too. And that side is that people have pushed college and degrees and management and business and finance and all these positions, right? The tradesmen have been put to the back for a long time. And I can tell you right now that I have a strong belief that electricians are going to be the most valuable working asset
You betcha.
in the next 10 to 25 years.
Yeah.
Because nobody is going to be able to do what these people do. And now that's why it's time for us now. It's impossible for us to get ahead of it because we're already behind it. But there was a huge push to, hey, don't become an electrician. Don't become a plumber. Don't become a carpenter. Go to college, get a degree. You're going to get a good job. You're going to do this. But the bottom line is the most valuable man in America is the blue collar working man, because the blue collar working man is who built this country.
That's right.
And it's who is going to continue to build this country. The businessmen, they're going to help move the money, but you can move as much money as you want. If you don't have the people to build it, it will never get done.
Yeah. It's huge demand.
Yeah.
Yeah. And I don't see any of the colleges. I've been picking on the colleges on this podcast a little bit, universities, a little fed up because they're not teaching those jobs.
Well, and this thing is, and I saw some of this, talking about is where is that thing? And you're looking at like the community colleges are catching on.
I hope so.
And they're saying, hey, if we change our program from business to trade and can support the trade industry, they're getting the buy-in from other companies to help support those programs. Mm-hmm. And because it becomes feeders.
Yeah.
And I can go in and I can select and say, hey, do that. But they're also seeing that that's where the need is.
Mm-hmm. When I was in school for VOTEC, I went to VOTEC while I was in high school for electrical.
Okay.
A lot of people don't know that about me, but my junior year, we started a 2-year program, and I actually went to electrical trade school while I was in high school. It was half my day. So I went half academics, half trade. And when I was there, I had a scholarship offer to one of the most prominent engineering schools in the country for electrical engineering that I turned down. And I thought it was the worst choice I ever made. I think I may have spoke about this the first time I was on the show.
Maybe.
I think it was the worst. I thought at the time it was a terrible decision. I don't regret that decision at all. And in fact, I recently talked to an engineer, a close friend of mine, and I told him, I said, hey man, I kind of want to go back for my bachelor's for electrical engineering. And he was like, dude, I can draw, I can calculate, I can do all these things. He said, I wish I knew what you knew. He said, I really wish that I knew what you knew. He said, because drawing it doesn't mean nothing if you can't go out there and turn the wrenches and fix it, right? And eventually, especially where we're at with AI, those guys are going to be less and less needed as time goes on, because the software and the stuff that we're being introduced to, it's staggering.
We can get the AI to do drawings for us right now.
Yeah.
It's unbelievable.
Oh, yeah.
As a matter of fact, my son was teaching me this. I didn't even know.
No, it's crazy, man. You have got to be ready for what's soon to come, because it's going to be massive, and we're going to need a lot of tradesmen to do this work.
I love that. I'm always trying to give great career advice, and man, yes, go learn the electrical field. It doesn't,
or any trade. Go get a trade.
Any trade is good, but like we said, we're a power hungry society. So
the
electrical trade is a great one to get into.
Electricians, I forget that guy's name, but that guy who, he's an entrepreneur guy. I wish I could remember this guy's name. He was on there. He used to go to yard sales and buy cheap stuff and resell it on eBay and stuff like that.
Okay.
And he was trying to teach guys how to get side hustles going. And he said it. He said, electricians are about to go hard, like dumb hard. Yeah,
you remember this?
You know what I'm talking about, right? I'm telling you, he's like, they're about to go dumb hard.
Yeah,
because we have so much power demand.
Talking about Gary Vee?
Yes, that guy.
Oh,
that guy. He said,
right.
he said,
I don't know this guy.
He said electricians are about to go hard. He said because and they're going to, trust me. I mean, me, we were all at RE Plus, right? Mark was there, right there with me. We saw each other a few times. Dude, every transformer manufacturer I talked to was struggling to service their assets. Every single one. And I'm telling you, there was guys, heavy players we walked up to. They looked like it was Christmas morning when we told them that we were servicing transformers, because they are struggling to get their assets serviced.
Unbelievable. Well, I'm glad you guys are in it. I'm glad you guys are taking care of it, and keep going. Keep growing, because it's not just servicing the assets, but boy, you're servicing society when you're teaching people and sharing education and knowledge when you're out there. It's brilliant.
Well, you have to, man. You have to, because, the end goal is to create awareness, right? so that people know what to deal with. You know, last call I ever want to get, no matter if we're involved in or not, is that someone was injured in an electrical accident or there was a catastrophic failure on something. I mean, you know, where we have grown in the industry is that everything is going towards the utility sector, like almost everything, you know, and the power that we need, like you talked about, is in that same sector. Right. So you're going to have more and more. Years ago, 10 years ago, it was rare to have a technician on a solar plant interfacing with 60 to 70 medium voltage transformers every day of their life, right? Let alone a substation, right?
Right.
Now, I mean, that was a rarity. Like if you worked on those projects, you were kind of like the king. You were like,
sure.
Oh shit, y'all ain't nothing. I'm out here working on high voltage stuff. We got a substation on this project. We're in the utility business, right?
Goodness.
Like there was a lot of technicians back then that were only being exposed to at maximum, you know, 1,000 volts DC, 480 volts AC on those systems. They weren't dealing with transformers. They were dealing with switchboards, right? And they didn't have these kind of risks. We now, I would say 90% of the technicians are at minimum around medium voltage, primary, in the essence of 34.5, sometimes above, every day of their life, you know, because you need these people out here to service these assets. I mean, if you think about the central inverter game now, pretty much every central inverter has a medium voltage transformer attached to it.
Yeah.
You know, and
or they stack 2 to 4 inverters together and then give you
one transformer. I mean, I went out and did a project. I won't put one of my clients' names out there, but we went out and serviced a transformer. Completely blew me by storm. It was, I thought I was walking into a standard PV inverter with an MVT. No. It was a skid with basically an AC distro board attached to an MVT that had string inverters in the field.
Oh.
So now they're getting to the point where now even these skids are starting to become not just an inverter MVT combination unit, but now they're basically creating their own AC switchboard attached to the MVT, and that is sending the AC back out to string inverters located in the field. And part of it
those are older technology though. We're not doing many strings anymore. String inverters.
Oh yeah.
We're still doing string inverters?
They're coming back around.
Really?
Oh yeah.
I didn't know that.
Because of the maintenance that can come to it and the cost efficiency and things like that, you're going to see string inverters popping back out.
So I'll tell you why. There's several reasons why. The first reason is you eliminate combiner boxes entirely, right?
Okay.
You put the string inverter at the array, all the strings, all the PV wires come in, right? Your wire going back to that skid that I'm referring to is now an AC
straight AC
system instead of a DC one, right?
Yep.
You're also getting yourself to a position where, oh shit, if my transformer loses if my inverter loses a power supply or loses, you know, a power stack or something
Smaller
like that,
loss.
It's a smaller loss on the production hit for the end user. So now you're like, okay, if I have a transformer and a distro board that's servicing, let's just say 20 inverters, right? And I lose one inverter out of that 20 instead of losing the whole inverter.
Large loss.
That's a much smaller loss than losing an entire central inverter.
I didn't know we were doing that utility scale. I was going back. I mean, I built my own on my house about 5 years ago, 4 or 5 years ago, and I went microinverter and for the same reason. I was like, oh, modular. This is
beautiful.
This is a simple answer.
Yeah.
But I didn't think we were doing that in utility again.
It's happening. It blew my mind. When I saw it, I opened the cabinet, and again, being aware of your surroundings, showing up, every circumstance is different. I'm just assuming we do work for this client all the time. I walk into central inverters every single time. Our team, no matter who it is, where we are in the country, it's a central inverter. Nope. Walked up and it was literally an AC distro panel with its own MVT on a skid, full inverter skid setup, just like a central inverter. Mm-hmm. And they had that project's pretty big. I don't know the capacity of that project. but I think they said they had like 100 to 150 string inverters on that project, and they had blocks. It was about 80 blocks. So they had at least, I think there was 88 of those AC distro transformer setups spread throughout that site, and every single one of them had numerous string inverters attached to them.
Yeah, no, we did a job early this year. We swapped out like 200 string inverters on one site, old model, upgraded model, something like that. And
well, they're the answer on the repower side. Like I tell people, like that site that we just did for you guys had, they had like 13 or 14 260 kW central inverters, like old AE central inverters, like PV powered, right?
Okay.
And, you know, when you see people repower them, more and more people are going to like a SunGrow string inverter or something similar because of the size of the string inverters and just the advancement in technology. It just makes more sense. You know what I mean? And a lot of those central inverters back then, due to the size, you didn't have an MVT per central inverter. You had exactly what we faced when we showed up to that job. You have, you know, I think we had, between both of those sites, we had probably about 24 inverters close to between the two. There was about 12 or 13 per site. There were 4 transformers between the two projects.
Gotcha. You made the comment, answer to repower. I don't know if it's the answer, but I love that it's an option, right? Because there's been so many companies that came out with different components like the different inverters that aren't supported and maybe don't run so well. Huge cost to swap them out. An option could be get rid of it, put string inverters in.
100%.
Yeah, I
100%.
hadn't thought about it that way. You don't have to stick with what you have. I don't know if the economics work, but electrically, I get it.
And sometimes it's, you know, when it's where the economics is, well, where's that string inverter fit?
Yeah,
It in the long run, it's one less thing to maintain.
yeah.
So when you look at the
Well, it's
big
really
picture,
cool. I hadn't thought about that.
And you get warranties. You know, that's the string inverter situation answers a lot of problems, because part of the problem that people are having is that the central inverter technology has changed so much over the years that a lot of the input types and the transformers that were put on site to feed voltage to these units, they just don't work, right? So unless you find something that's like a refurbished option, this is common in the PV world with cable, right? Like when I go out and we used to replace like 1,000-volt PV cable, like collector cable, even standard PV wire for panels, right? You can't call and order 1,000-volt PV wire anymore. You're getting 2K, no matter what. So now that poses a little bit of a challenge, because let's say you had a combiner box that you're doing a repower on, or you're repulling cable because you had a problem, or like a lot of times we experienced people back at the old company where they had vandalism on these projects, right? Well, now you got a conduit fill that was based on 1,000-volt PV wire. Now you can only get 2,000-volt PV wire, and that outer diameter on that insulation is much larger.
Yeah.
Right. So now it limits the amount of circuits that you can physically fit into the conduit that you have. So it's a similar problem with this, with the specifications on the inverters and what you're actually dealing with on the inverter side. So, you know, no matter how you throw it, if you take a central to a string or vice versa, you have to rebuild one side of that circuit no matter what, right? Sometimes you have to retrench the AC side. You have to change like your transformer, but sometimes it's the opposite side. So I think that there's different costs and different savings depending on which way you go. And I think that a lot of clients are analyzing not just the construction cost, right, or the repower cost, but also what type of a production loss or revenue loss am I going to lose if I put a central inverter in place of this central inverter again and have an entire inverter offline, versus putting a handful of string inverters in place and losing a portion of the system instead of the entire inverter.
I love it. Hadn't thought about it, but it really does bring the options, and we need more options in solar because of all the different OEMs and the new components. But that makes sense.
And serviceability, that's another part of it too.
Yeah.
I tell people that all the time. That's a point that people oftentimes overlook, right? It's like, when you're selecting equipment, no matter if it's a new construction build or a repower, right? And a lot of these repowers that they're facing this is for this reason, because they decided to go with maybe a cheaper, more available asset that is not as serviceable. So now they're struggling to service the assets that they bought, which is costing them money, you know? And that is one of the biggest things that comes into play too. It's like, okay, we don't only want to pick a solid unit that is readily available or is easy to modify the build or repower, but we also want to pick assets that are easily serviceable and we can get service quickly, because the longer that we sit down with assets that are not operating, the more money we're losing.
Yep. I love it. Hey, we're kind of getting long on time. I want you guys to come back. I'd love to hear more about some of the things you're seeing from the field too, you know, lately. But before we wrap, is there anything else you guys wanted to hit today?
I don't think so.
Yeah, I appreciate you guys talking shop, talking safety, components, and then help educating the people that are taking care of sites what to look for, how to get ready when they have an event, if they have an event, so that they can get their site back online quickly. You know, call you, but having that information available helps themselves.
Oh yeah.
Yeah,
Definitely.
I love that. All right, thanks for coming, guys.
Oh, no problem.
No problem. Thank you.